So the next learning objective is to explain vector data model and differentiate between various vector features. A vector can be used to represent features of the real world. And a vector is basically a directed line segment. It, if we have 2 points, let's say A and B, then going from A to B can be represented with a vector AB. And if we are trying to save this information in a computer, all we need is to save the coordinates of the 2 points, and the order of the points will tell us that the vector is directed from the first point to the second point. We can use vectors to represent real features. For example, if we had a parcel on the ground, a rectangular parcel, we could, that means we have 4 corners, and we could represent this parcel, rectangular parcel, with 4 vectors back to back, and connected. The head of one is connected to the tail of the next vector, and these vectors represent a small rectangle. Similarly, if we were to represent a road on the surface of the earth, then it could be many vectors connected from head to tail in a sequence. And by extending the same idea, if we have a single point on the ground, for example, a hydrant or a manhole, then it could be a vector that has the starting and ending point exactly the same, or in other words, zero length vector. So we can see that a point, a line, and an area can be represented with vectors, and this could be a reasonable way of representing real world objects in a computer data model. So there are 3 types of features that we can represent with vector model. The first one is point. It of course has the same start and end point. It is a zero-dimensional object, and it can be used to represent point type features on the ground. Then we have a polyline, which is many vectors connected back to back. So the starting vertex and ending vertex are connected through many intermediate vertices, and they form a polyline. And this is a one-dimensional object that can be used to represent linear features. And lastly, we have the polygon type. This should be it is a polygon, but it's potentially a polyline, but its starting point is same as its ending point. So we go and close the loop all the way, and this way we get an area type feature, which is a two-dimensional feature. And if we were presenting something on the surface of the earth, that's all we need: point, line, and polygon. Now this idea can be extended to volume, and in that case we will have three-dimensional feature, which is called a polyhedron, which is not covered in standard GIS. So let's look at some examples of these 3 types of features. If we were looking at some real world, and we were trying to identify some vector features, the points could be water hydrants, stream gauges, accident locations, and in this example, the locations of customers. The polyline type vector features could be streets, rivers, track of a hurricane. These are all linear features. The polygon type vector features could be the boundaries of a campus or buildings or a lake, and all of these would potentially together represent the real world. Now, when we are talking about vector features, in this case, the points, lines, and area, they need additional information. This covers the geometry, but then we also need the attributes, which basically tells us what does this point, line, or polygon represent. And that is where the attribute data comes into play. So for example, if this is these are 3 points, they all will have an ID, and then there will be a table in which each ID will be further explained using the attributes. So in this case, this could be the center of a plot, and that the value, the first value represents the size of the plot. Then the next one, what is inside the plot, in this case vegetation. What is the class of the vegetation, that could be the third attribute. So we have in three attributes of this, including and along with one um, identification or identifier of the feature on the ground. Likewise, polylines could be in a similar way have attribute data. So in this case, these are um, pathways. So they all have identifiers 1, 2, 3, and then we have their IDs 1, 2, 3, and their one of the attributes is the type, road, dirt trail, um, or the third one is also a road. Then another attribute is their status, whether they're open to business or closed. And the last one is when how frequently are they maintained. So clearly, attribute data is what tells us what the vector features are representing. And you can go through this table, which is the polygon attribute table.